Welcome to Techflix. In this video, we would discuss about the concepts which are required prior to understand components of PLC. Before discussing about components of PLC, let's brush up few electrical fundamentals in prior to understand the workings of the components of PLC more easily. The first fundamental principle we need to know is Ohm's law. So, what is Ohm's law? Ohm's law states in the world of electricity, voltage or potential difference measured across a conductor is a product of current flowing through the conductor and the resistance of the conductor, which is V equals to IR. So, if we shift resistance to the LHS of this equation, we have voltage upon resistance is equal to current. This simple mathematical equation states, whenever resistance decreases, current increases. Or we can say, current is directly proportional to voltage, and inversely proportional to resistance. To correlate this, consider an insulator whose resistance is very high, hence no or minimal current flows through it. Whereas a conductor whose resistance is low than an insulator, large current can flow. Now, let's see a real-world example to get more clear about Ohm's law. Consider a voltage supply connected to a bulb. The bulb is nothing but a load or resistance in the circuit. The intensity of brightness of the bulb increases as current increases. Now, in this bulb the resistance is going to be constant. So voltage and current and so, the intensity of brightness of the bulb are all directly proportional. So you would observe, when we increase the voltage, the brightness of the bulb increases proportionally. Similarly, when we decrease the voltage, the brightness of the bulb decreases. As we are now clear with Ohm's law, let's discuss a very important concept in PLC, which is sinking and sourcing. You would observe here a very simple electrical circuit. The toggle switch controls the supply of the voltage to the bulb. So when we toggle, the bulb turn on and off. So in this example, you must have observed the bulb is connected to the source before the switch. That is, the current flows from voltage supply to bulb, and then to the switch. The simple circuit diagram of this circuit is shown as. So in this circuit we have two elements connected to the power supply, that is the bulb and the switch. So now, which element is sourcing and which element is sinking? Can you answer? You are correct, the bulb is sourcing, and the switch is sinking. Because the bulb is connected to source, and the switch is connected to ground. Now, observe this circuit. This is similar to the previous circuit, but you must have observed a slight change. Yes, now the switch is connected to the supply before the bulb. This circuit is again illustrated in this simple circuit diagram. Now it must be very easy to say which element is sourcing and which element is sinking. Yes, the switch is now sourcing, while the bulb is sinking. So now, I hope the sourcing and sinking concept is clear. Now, let's replace the switch with a PLC. What is COM, what is I0, that we would discuss in further tutorials. Now just consider the PLC replaced a switch. Also, the PLC is sourcing, right? Next, let's also replace the bulb with a sensor. A sensor converts physical data such as temperature, pressure into an electrical signal. The sensor is sinking, right? Let's swap the sensor and the PLC. Now we know, the PLC is sinking, while the sensor is sourcing. I hope we understand now, what is PLC, sinking, and sourcing, and what is sensor, sinking, and sourcing. Now, we know about sourcing and sinking concept in PLC. But the question is how to use them, because any of the either way would work. So, first of all, remember sourcing and sinking concept only applies to DC power system, and not the AC power system. The reason is very obvious, in AC the direction of current in loop is alternating. So there is no sinking in the circuit. Every PLC have its own method of wiring. Some PLC can be sourcing type and some may be sinking. Even the sensor may be sourcing or sinking. So, the best practice is, when PLC is taking any input, it should be sinking, whereas the sensor should be sourcing. The reason behind this is explained as: suppose the cable from source to sensor or sensor to PLC breaks. This will develop a ground and the current would not return to PLC, causing a open circuit. So, we would come to know the sensor is broken or the connection is broken. And then we can replace the sensor. Now, imagine, we use PLC as sourcing, when it requires input from sensor. What will happen even if the line is broken, the circuit is still closed. So the PLC will not come to know about sensor or cable is broken or not. The value of that sensor will be always high and that can cause a major damage in operation. Now, imagine when the PLC needs to give digital output, for example, opening or closing of a valve. In this case, the best practice is PLC should be sourcing while the output should be syncing. The reason here is safety. As shown, the PLC is sourcing and the output is syncing. In this case, if the cable from output to PLC or source breaks, the circuit would be open. And the output will stop. Even if the output stops, it will not affect another loops of the PLC program, as compared to the input given by the sensor, which is used to process the PLC program. But, if the PLC is syncing while the output is sourcing, the output will always have a supply even if the cable breaks. This is a dangerous condition. Suppose the output is outlet valve of any acid tank, that prevents the overflow of tank. When the valve will be always powered, the tank may overflow and cause catastrophic damages. So, we understand now that, whenever PLC is giving output, the PLC should be connected close to source, that is, sourcing. And, whenever PLC is taking input, the PLC should be connected close to ground, that is, syncing. That's all for this part of the video. In next part, we would discuss about the power supply, input, output cards of the PLC. That's all folks. In next video, we would discuss about the components of PLC in details. Please subscribe our channel to get latest videos on automation. Also don't forget to press the bell icon. Jai Hind, Jai Bharat.